Hello friends! Today we'll go over a few different strategies that you can use to help you when you inevitably get stuck. I've already attached a script to the scene's root node named debug. You've probably noticed the autocomplete feature that is available if you specify the type of your variables. This not only allows you to see all of the properties and functions of the class, but after selecting a function, you can also see the types of all the function's parameters so you can provide matching arguments. Also, when you know the types of all your variables, this makes type mismatch errors clearly apparent, and you'll be warned of the error without having to run it. Without strict types, the engine doesn't know what is mismatched until attempting to execute the line. If you want to browse through a built-in class like color, we can easily access the information by clicking on either of the buttons in the upper right corner of the panel. Online Docs opens a tab in your default web browser to the Godot API matching the version of the editor that you're using. Here you'll find basic information about Godot, tips on getting started, detailed tutorials on the basics, community links where you can find additional resources, and a complete class reference. As you can see, there are a lot of classes. And selecting any of them, we can see what they inherit from, and what other classes they are inherited by. Each has a description of what it does, links to tutorials on how to use it, a list of properties, and methods. When talking about classes, we tend to refer to variables as properties and functions as methods. There are also signals, something Godot uses for automatic communication between nodes, enumerations, and constants, like we have used before. All of these have their own subsections and descriptions of how to use them. Back in the Godot editor, Search Help opens a window in Godot where you can see a list of every class. Selecting a class, we can see all of the same information that is available from the Godot website in our editor, so we can access it offline. Returning to our script, we can even access this information easier by holding down the Control or Command key, then clicking on a class name, bringing us straight to the reference information for that class. The same can be done for specific functions and variables. Clicking on them not only opens up the reference page to the class, but also brings us to the function or variable that we clicked on. There are also global functions that we can use, mostly to perform mathematical operations, like clamp, for example. If we use this function, we can see the parameters it is expecting, and we can use it to clamp our variable to be between 0 and 1. Holding the Control or Command key and clicking on the name of the global function will allow us to access the reference for this function, complete with a description and how to use it. These are all contained within the global scope class. I'll add another variable and another line to my script. If we run our scene, we can view the scene tree of the running simulation through the scene panel by clicking on the remote toggle. This is not the same scene tree in the local tab that we build to define the scene, sort of like a blueprint. This scene tree is the one that was constructed by the engine to run the scene. Selecting any node, we can see its properties in the inspector, and we can see that the ready function has already run since the colors have different values. We can change the values of any of these properties too. We can also use print to print out whenever we want to see what our variables hold at any moment. And it helps to be as descriptive as possible with your print statements so there is no confusion about where they are coming from. But if we change things up and use the process function, I'll just change the color gradually over time, then add a print statement here. Since this process function is running 60 times per second, the print statement's value as a debugging tool is greatly diminished, since the output log is just going to repeat the same message faster than we can possibly read it or react to it. We can pause the simulation while it is running using the pause button or pressing F7. This allows us to see the remote scene tree as it is at this moment and review the contents of the output panel with the simulation paused. But this still isn't very useful, as several frames will be completed between the time when the simulation starts and when we can pause it. If we click to the left of any line of code, we can add an automatic breakpoint indicated with a red circle. When we run the current scene, the simulation will pause when it reaches this line, before executing it. This is much more helpful if we want to see our simulation run one frame at a time. Now we can see how each frame the color gradually changes one frame to the next. Let's have our process function call another function to perform a simple task. I'll just change the color gradually by reducing its red value. So now we should see the color gradually change every frame, becoming less red and more blue. With the breakpoint still at the first line of the process function, I'll run the scene. It stops here and we can see that the next line of code to be executed is indicated with a yellow triangle. While the simulation is paused like this, we can tell it to execute only a single line of code at a time, rather than an entire frame, by selecting Step Over from the Debug menu, or using the shortcut F10. This will execute only the line of code which is pointed at by the yellow triangle, then immediately pause again. So we can see the changes made only by that single line of code, and we can see the yellow triangle point to the next line waiting to be executed. We can continue running our script line by line if we continue stepping over, until the process function ends and the frame is complete, returning to the top of the process function to run a second time. Now we can watch each individual change to the color as its blue value is increased separate from when the red value is decreased, even though they happen during the same frame. In the case of function calls, there is another option to step into the function. If we select this option or use the shortcut F11, the yellow arrow will instead step into the function being called and execute that one line at a time until its completion. When the function is complete, the yellow arrow returns to the original function to continue executing that one. Using these tools, we have a very focused view of what our classes are doing and when, how they are behaving, and we can watch them in as slow motion as we need to figure out what is going wrong at what specific moment in time. If you can't solve a problem yourself, the Godot community is very helpful and always willing to lend a hand. There are Discord servers for Godot developers, including my server where my students help each other out. The link to join is in my profile. There are also online forums on websites like Reddit where you can ask questions too. You now have a basic understanding of most of GDScript's syntax and the tools needed to explore these concepts further. When you're ready, please ask me for a discount code to any of my game project courses. And good luck.